Hello, let's evaluate this integral I equal to integral 0 to infinity e power minus of x square plus y square by 2 sin xy dx dy. So now let's start. As you can see, exponential there is x square plus y square by 2 and dx and dy. So let's transform I into polar coordinates. In the polar coordinates, x equal to r cos theta and y is r sin theta, right? Then what about dx dy? How will they change into dr d theta? What is the relation? You need to find the Jacobian, right? Or you can, if you know the formula, you can write directly as it will be r dr d theta. So if you want, right, first let's find out Jacobian. Jacobian is dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta, right? This will be dou x by dou r will be cos theta, dou x by dou theta will be r into minus sin theta, right? Dou y by dou r is sin theta, dou y by dou theta is r cos theta. The determinant is r cos square theta minus of r sin square theta. Then it will be plus this is r, right? Sin square theta plus cos square theta is 1. So this value here it is r, that is dx dy is r into dr d theta. Fine. Now as you can see in the integration limits, x and y both ranges from 0 to infinity. That is, if you draw x and y axis in Cartesian coordinates x and y, if this is 0, then this is covers entire x axis, right? That is, it is in the first quadrant, that is r plus region. So the limits in polar coordinates form will be the limits in polar coordinates r will be from 0 to infinity, right? Theta will be from 0 to pi by 2. So it covers the first quadrant, right? Then I will be integral 0 to pi by 2 for theta, and for r it will be 0 to infinity e power minus x square plus y square, right? X square plus y square is r square by 2. Then sine of xy, right? It will be r square, right? Sin theta cos theta into dx dy is r dr d theta. Fine. Then let's do some simplification here. This can be written as integral 0 to pi by 2 integral 0 to infinity e power minus r squared by 2 into sine of multiply and divide by 2. Then this will be r squared by 2 into 2 sin theta cos theta, right? Which will be sine 2 theta r dr d theta. So here, as you can see, in exponential and in sine, there are r square by 2 terms, right? So let's consider r square by 2 as t. Fine. As you can see, the integration limits will not change. I mean, if r tends to 0, then t tends to 0. If r equal to infinity, t will be infinity. So I equal to 0 to pi by 2, right? So what about this? Half into 2r dr equal to dt. Still with this. So r dr is dt. Then this will be 0 to infinity e power minus t sine of t into sine 2 theta, right? Fine. Then this r dr is dt into d theta. Fine. Let's consider here, we will calculate first the r term. I mean here the t term. So then let's consider, I mean we are not substituting any limits, we are just making it, we are just evaluating this value tt first, then t to sine 2 theta will be constant, right? So without getting, so that we will not get confused, I equal to 0 to pi by 2, this will be integral 0 to infinity e power minus t into sine of ts dt d theta. That is, we are just evaluating our t case, our two case. First evaluate this case, integral 0 to infinity e power minus t sine of st dt. When we evaluate this value, the s value will be sine 2 theta, and we'll integrate integral 0 to pi by 2 d theta. Fine. This is in the standard form, right? This is standard integral, which is integral a power x sine bx dx is a power ax by a square plus b square into a sine bx minus b cos of bx. If you compare to our integral here a is minus 1 and b is yes, right? I mean the integrating variable is t there, here it's x, right? Then integral 0 to infinity e power minus t sine of st dt will be e power minus 1, right? X is here t by minus 1 square is 1 plus b square is s square. A square is minus 1 sine of st, b is 1, right? Minus is cos of st. Fine. Then here in our case, this integration limits are 0 to infinity, right? 0 to infinity. Then this integral value will be, when t equal to infinity, this will be 1 by infinity is will keep 0, right? And this will be 0 minus of, let's see, when it is 0, t is 0, e power minus 0, it will be 1, 1 by 1 plus s square into, right? And this, what about this? When t equal to 0, this will be 0 minus 0, right? Then when t equal to 0, this minus is for everything, right? When t equal to 0, this will be 0 minus 0 minus, when t is 0, cos 0 is 1 minus s. Then this will be 0 minus of, this will be minus s, minus 9 to minus will get plus, s by 1 plus s square. So ultimately integral 0 to infinity e power minus t sine of st dt is s by 1 plus s square. That is here integral 0 to infinity e power minus t sine of s is sine 2 theta, right? Sine 2 theta into t dt is s is sine 2 theta by 1 plus sine square sine 2 theta. We need to evaluate d theta part, right? Which is integral 0 to pi by 2. As you can see here, this we need to evaluate this part now. Integral 0 to pi by 2 sine 2 theta by 1 plus sine square 2 theta into d theta. So let's do one thing here. This integral 0 to pi by 2 sine 2 theta by sine square theta can be written as 1 minus cos square theta, right? Here sine square 2 theta can be written as 1 minus cos square theta 2 theta. Then 1 plus 1 will get added, which will be 2. 2 minus cos square of 2 theta d theta. So here let's consider cos 2 theta as u, right? Then if this will be, if you differentiate, this will be minus 2 sine 2 theta d theta equal to du. What about the integration limits? If theta equal to 0, that means u will be 1. If theta equal to pi by 2, that is this will be cos 180, which is u equal to minus 1. Then I will be integral 1 to minus 1 sine 2 theta d theta is minus half du by 2 minus u square. Fine. Then this will as you can see, because of this minus symbol here, minus half, this can integration limits will get changed. This is minus half to minus 1 to 1 half du by 2 minus u square. As you can see, this is an even function. This can be written as half into 2 times of 0 to 1 du by 2 minus u square, right? So I can be written as integral 0 to 1 du by root 2 whole square minus u square. You can use directly the formula 1 by a square minus x square, right? Or else you can solve this case. So I mean, let's do simple calculation here, right? This can be written as root 2 plus u into root 2 minus u, right? Then this can be written as 1 by root 2 plus u plus 1 by root 2 minus u. Let's try this. If it's minus here and plus here, what will be the numerator? In the numerator it will be root 2 plus u plus root 2 minus u, right? U will get cancelled, you will get 2 root 2, right? So do one thing, divide it with 1 by 2 root 2. Fine. Then this will be same as at the left hand side. So I will be I equal to 0 to 1. This will be keep 1 by 2 root 2 out of the integral. Then this is 1 by root 2 minus u plus 1 by root 2 plus u into du. That is I equal to 1 by 2 root 2 into, if you calculate this first case, it will be ln of root 2 plus u. Then what about this case? This will be ln of root 2 minus u by minus, right? So this will be minus of ln of root 2 minus u. Integration limits 0 to 1. So I is 1 by 2 root 2 into ln of root 2 plus u by root 2 minus u. As integration limits are 1 to 0, there is no need to add modulus here because they are positive anyway. So this will be 1 by 2 root 2 into ln of root 2 plus 1 by root 2 minus 1. When u equal to 0, it will be root 2 by root 2. Then ln 1 is 0, then it will not contribute. So leave as it is. So let's try to make it more simplified version. 1 by 2 root 2 into ln of root 2 plus 1 by root 2 minus 1. Let's rationalize the denominator. So this will be 1 by 2 root 2 into ln of root 2 plus 1 whole square, right? By this will be 1, right? Root 2 whole square minus 1 will be 1. Then this will be, as you can see, ln a by b is ln root 2 plus 1 whole square minus ln 1. ln 1 will be 0, then it will not contribute. So you have 1 by 2 root 2 into 2 into ln of root 2 plus 1. This 2 will get cancelled, and this will be 1 by root 2 ln of 1 plus root 2. Finally, our solution is integral 0 to infinity e power minus x square plus y square by 2 into sin xy dx dy is 1 by root 2 ln of 1 plus root 2. So that's it.